Hi everyone, my name is Chaitanya. I am pursuing BTech second year from ECE branch. Today onwards, I am explaining a converging of flip-flops and latches and understanding the techniques. Now, what are flip-flops and latches? Now, both flip-flops or latches are fundamental basic circuits with digital circuits and serving as basic memory units to store a single byte of data, either 0 or 1. Yeah. Latches are level triggered. Their input output can change as long as enable input is active. They are transparent during this period. Flip-flops are age triggered. Their output changes only at specific transitions of clock signals, either rising or falling. Okay, next, making them a more synchronized. Now, essentially, flip-flops is a clock latch providing a synchronous data storage, which crucial for building complex memories. And elements and sequence logics are circuits. Next up. Now, four basic flip-flops are four basic flip-flops types. What is SR, JK flip-flops, D flip-flops, and trigger flip-flops. SR signals means set reset flip-flops. This essential, this simple type controlled by sets and resets inputs. It has valid at state when both S and are active simultaneously. Next, D flip-flops, often called a delayed flip-flops. It stores the data present at its input D inputs on the active clock edges. Now, widely used in the registers and memories. JK flip-flops, an essential version of SR flip-flops that avoid the valid states and when both J and K inputs are high, it toggles its outputs. Now, T toggle flip-flops. This flip-flop toggles its output state. Flip-flops from 0 to 1 or 1 to 0. Each time a clock pulse is applied and the T input high. Useful in current designs. Why conversion flip? Why convert flip-flops? The ability to convert between different flip-flops is a visual skill in digital designs, offering several practical advantages. Components availabilities. Certain flip-flop types such as J, K, and D are more commonly available as integrated circuits than other like SR and T. Conversions allows you to use what you readily accessible. Logics implementation. It provides the flexibility to implement desired sequential logics using a flip-flop types that might not be a directly suited for the tasks by leveraging another variable types. Designing optimizations. Conversion enable engineering to optimize the circuit design for factors such as component counts, power consumption, or specific timing requirements. Now, basic principles of flip-flop conversions. Silence. Now, the core idea behind flip-flops conversions is used combination logical to bridge to function gap between the desired flip-flop behaviors and available the flip-flops inputs. The input of the desired flip-flop, the one you want to enhance, become the primary inputs or combination circuits. These combination circuits then generated the necessary input for the available flip-flops. The only one you using, you make it behave like the desired type. The output of this combination logic feeds directly into the control inputs. Example, S, R, J, K, D, T of the available flip-flops are required. Now, examples for converting the one flip-flop to another flip-flop. Now, converting an S flip-flop to a JK flip-flops. Select ones. Let's illustrate with common conversion transferred and transforming as S flip-flop to into JK flip-flop using external logics. Now, first one, truth table analysis. First, we analyze the truth table of a JK flip-flops, considering the inputs JK and current states and Qn to determine the next state Qn plus 1. Derives S and R inputs from the JK truth table. We derive the required S and R inputs from the undelivered SR flip-flops to achieve the JK behaviors. S equal to J into Q bar. Here J and not Q end. Here R equal to K into Q of K end of Qn. Now implementing with the logic gates. These derived equations then implemented using simple AND gates. These inputs, these AND gate feed directly into the small S and R inputs. So available SR flip-flops effectively creating a JK flip-flops. Now converting SR to D and T flip-flops. Now the SR flip-flop is a veristical from the conversion to due to its basic sets and result function. Here are more examples. SR flip-flop to DR flip-flop conversions. Now the conversion and SR flip-flop into a D flip-flop, we ensure that the S and R inputs are always complementary and prevention the invalid state and allowing the D inputs and directly control the next states. Here S is equal to D, R is equal to D bar. Now this conversion requires just a single NOT gates connected to the R inputs with the D inputs connection to the R has S to T flip-flop conversions. For a T flip-flop, the inputs toggles when the T input is high and clock pulse arrives. This behavior can be achieved from the S flip-flop by controlling S and R on the current output states Qn. S is equal to Q into Q, T into Q, and R is equal to T into Q, T and Qn. This conversion uses the AND gate and one NOT gate. Verification table. Verification the truth table. After desiring a flip-flop conversion, it crucial to verifying its coherence, and this typical done by the construction a truth table. for this conversion circuits and comparing the its against the desiring a flip-flops characteristics truth table. First construct the conversion truth table and list all possible inputs combinations from the desiring flip-flops. Now, calculate the intermediate signals and design the outputs of the continuous logics. Example, SR values are the SS flip-flops. Determining the next state, use the calculate the intermediate signals and characteristics table for the available flip-flops to find the next state Qn plus 1. Now compare and confirm the ensure that the every input combination Qn plus 1 combined from the converted input matches, and the method verifying step ensure that immediate immediate logic accurately and replacing the intention behavior. Visualizing flip-flops and latches relations. Now first, the distance between the level triggering latches and edge triggering flip-flops can be beautifully illustrated by how a flip-flop conversion from now master slave configuration. A common method involves the connecting two latches in a master slaves configuration. Opposite clock pulse. The latches are enabled on opposition clock pulse while the master latch is active. The slave is inactive and vice versa. This sequential enable to allows the data to pass only during the specific clock transformations. Now finally, the edge trigger behavior. This arrangement effectively transforms the level triggered nature of individual latch and into the edge trigger behavior of a flip-flop. Ensure that data is captured and output synchronously. Thank you, everyone.